Good morning to one and all for today's morning session of metal cutting and forming. So today we will be discussing about module 4. In module 4 we are going to discuss rolling. Okay. So you can see the direction of the workflow in the sketch. Okay. Direction is shown in this way. Okay. The direction of the workpiece, that is shown in this way. Okay. And you all can see this portion is a workpiece, which is rectangular workpiece, and at the top and at the bottom there are two rolls. Okay, and this is the direction of roll is flat rolling. Okay. Next, what is rolling? Rolling is a metal forming process in which the thickness of the work is reduced by compressive forces exerted by two rolls rotating in opposite direction. Flat rolling is shown. Flat rolling, you all can see this is the flat rolling which is shown the direction flat rolling. Okay. Similarly, shape rolling is also possible, like a square cross section is formed into a shape such as I-beam, L-beam, etc. Okay. So important terminologies, that is important terminologies, you all can go through that. Bloom, it has a square cross section 150 mm into 150 mm or more. Slab, and slab, it is rolled from an ingot or a bloom and has a rectangular cross section of 250 mm width 250 mm width or more and thickness 40 mm or more. And next one is a billet. It is rolled from a bloom and is square in cross section with dimensions 40 mm on a side or more. Blooms are rolled into structural shapes like rails for railroads. Railroad tracks you might have seen. On that, blooms are rolled, and billets are rolled into bars, rods, etc. They become raw materials for machining, wire drawing, forging, extrusion, etc. Okay, slabs are rolled into plates, sheets, and strips. Hot rolled plates are generally used in shipbuilding, bridges, boilers, welded structures, for various heavy machines and many other products. Okay. The plates and sheets are further reduced in thickness by cold rolling to strengthen the metal and permits a tighter tolerance on thickness. Okay. Important advantage, you can see here, important advantage is that the surface of cold rolled sheet does not contain scales and generally superior to the corresponding hot rolled product. Later, the cold rolled sheets are used for stampings, exterior panels, and other parts used in automobile, aerospace, and household appliance industries. Okay. Next, you all can see the bloom. How the sketch of the bloom. This is the bloom shown here. And structural shapes, you all can see this is a structural shape. This whole is a structural shape. And rails, road rails, railway tracks, you might have seen the rails. And the slab will be in this kind, and plate sheets will be in this shape, and coils will be rolled, that is roller like. And these are the billets, and these are the bars, and this is the bars, and this is the rods. Okay. So next we will be discussing about rolling mills. Two high roll mill. This type of rolling mill consists of two rolls rotating in opposite direction. You all can see in the sketch. The sketch itself shows that two rollers, one, and this is two rollers. Two rollers are shown above and below the workpiece. This is the workpiece. Okay, this is the workpiece, and above and below the workpiece there are two rollers, and you all can see the arrow mark shown. The direction is shown opposite to both rotates in the opposite directions. Okay, this will rotate clockwise and this will rotate anti-clockwise. Okay, so what they are told, this type of rolling mill consists of two rolls rotating in opposite directions. Roll diameters 0.6 to 1.4 meter and types either reversing or non-reversing. Non-reversing mills rolls rotate only in one direction and the slab always move from entry to exit side. Reversing mill direction of roll rotation is reversed after each pass so that the slab can be passed through in both the directions. Okay, this permits a continuous reduction to be made through the same pairs of rolls. So you all can see this sketch contains two high rolling mills. Okay, you all got this, the concept of rolling mills. Next we will be discussing about three high rolling mills. So similar things we will be seeing compared to the two high rolling mills. Here you all can see three rolling mills. This is one, this one is two, and this one is three. Okay, this is the third rolling mill. Okay, three rolling mills are there. Okay, so you all can see that by viewing the sketch you all can guess the direction of the roll mills, rotation of the direction of this is having this direction, and this will rotate in this direction, and this one will rotate in this direction. Okay, so you all can see this. In this case there are three rolls, one above the other. Okay, two rolls above and bottom of the workpiece there are two rolling mills. So the roll direction at a time for a single pass two rolls will be used. Okay, two rolls will be used. So the roll direction you all can see here, roll direction will not be changed in this case. The top two rolls will be used for first reduction and sheet is shifted to the bottom two rolls and further reduction is done. This cycle is continued till actual reduction is attained. Disadvantage, automated mechanism is required to shift the slab. Okay, what is the important thing here? Automated mechanism is required to shift the slab in three roll millings. Next we will be discussing about four high rolling mills. Four high rolling mills, you all can see here one, this is two, this is three, and this is four. There are four rolling mills. Okay. Three, two, and one. Okay, four rolling mills. This consists of two small. You all can see the sketch. Two small rolling mills are there, and which are moving in opposite directions or rotating in the opposite directions, and two big rolling mills which rotates. These also rotates in opposite directions. Okay. This consists of two small rolls for thickness reduction and two large backing rolls to support the small rolls. These are the supporting roll mills. The small rolls will reduce the roll force required as the roll sheet contact area will be reduced. The large backing rolls are required to reduce the elastic deflection of small rolls when sheet passes between them. Do you all got? The large backing rolls are required to reduce the elastic deflection of small rolls when sheet passes between them. So this is the difference between four high rolling mills and three high rolling mills. So next we will be discussing about cluster rolling mills. This uses smaller rolls for rolling. You all can see in the cluster rolling mill 1, 2, 3, 4, 5 and 6. So 6 rolls we have, and the direction also has been shown of the rotating rolling mills. The direction has been shown with the arrow mark. Okay. Next will be a tandem rolling mill. In tandem rolling mill, the difference is the comparative to others. This consists of series of rolling stations of the order of 8 to 10. You can see these all rolling mills are arranged in a series of stations. You can see 1, 2 and 3. Okay, order of 8 to 10. In each station, the thickness reduction is given to the sheet. With each rolling station, the work velocity increases. This is fully used in industry practice along with the continuous casting operation. This results in reduction in floor space, shorter manufacturing lead time. So remember, in tandem rolling mills, the reduction in floor space, shorter manufacturing lead time is 10. So this is about tandem rolling mills. Next we will be discussing about thread rolling. So you all can see the figure here. In thread rolling, whatever, this is a die, fixed die this is, and this is a starting blank, and this is a moving die, and this will the finished part obtained. The part is, or you can say the component or the product obtained. Before it will be in this position, next will be second, it will be in this position, and afterwards it will be in this position, and lastly the finished part will be in this position. Okay. Thread rolling is used to create threads on cylindrical parts by rolling them between two dies as shown in figure. Between two dies, this moving die and the fixed die, between these two dies, that starter blank has been holded. Okay, between two dies as shown in figure. It is used for mass production or external threaded parts like bolts and screws. Okay.